We usually think of light as a fast, unstoppable force that bounces off cities or passes through clear objects. But can light be frozen? Recently, in a surprising scientific experiment, Italian researchers managed to turn light into a supersolid. This research is a major breakthrough not just for theoretical physics, but also for quantum mechanics. During this study, they focused on exploring light. The team was led by Davy Negro and Antonio Gianfrate, who are associated with the University of Pavia and CNR Nanotech. Any information shared in this video will have links to the articles published on it in the description. This research was published on March 5th in the renowned scientific journal Nature and has surprised experts in physics. During this study, scientists introduced light into a rare and complex quantum phase, where light showed properties of both liquid and solid at the same time. This is the same phenomenon. Supersolids are typically seen at extremely low temperatures. The concept of supersolids was first introduced in the 1960s, and it was observed in specific gases for the first time in 2017. Italian researchers wanted to find out if they could create similar conditions for light. To do this, they used a semiconductor, which is a material that can control the flow of light and electricity. The key question here is, what exactly is a supersolid? And how can light behave in such a way? Superfluid is a weird quantum state that has two opposite properties at the same time. It's like a solid state where particles can be arranged in an organized, mesh-like structure. At the same time, it's also like a superfluid state that can move without any friction. Trapping light is an astonishing example in quantum mechanics where regular physics rules don't apply. Before this, it was only observed in extremely cold atomic gases, known as ultra-cold atomic gases, at temperatures close to absolute zero. Scientists have brought light to an incredible new state at a temperature of 273.15 degrees Celsius, which is just above absolute zero. For the first time, they've managed to trap light in this special quantum condition. You might be wondering how they pulled off this amazing experiment. Well, they used a photonic semiconductor platform made of aluminum gallium arsenide. They fired a high-speed laser beam onto this platform, which arranged the light particles, or photons, in a specific way. As more and more photons gathered, this light behaved in fascinating new ways. Einstein's condensate, or BEC, is a special state of matter that forms at extremely low temperatures. When the atoms of a gas are cooled down to near absolute zero, which is about negative 273.15 degrees Celsius, they all fall into the same energy state and cluster together to create a superatom. Just so you know, this state was first theoretically proposed by Satyendra Nath Bose and Einstein in 1924, but it was experimentally confirmed in 1995. In a Bose-Einstein condensate, BEC, all the particles come together in the same quantum state and start moving in sync. After becoming a BEC, light started showing off some supersolid properties. These properties included having a specific structure and moving without any friction. While the first property made it solid, the second one revealed that light behaves like a superfluid. This is the first time anyone has forced light to adopt such quantum properties. And it's a groundbreaking discovery in the world of physics. Now the question is, it's basically asking what changes this discovery could bring to science and technology. This research isn't just a scientific investigation, it also has practical benefits that could be really significant. It could lead to new advancements in quantum mechanics and quantum computing. This discovery might help improve special conditions of light, making quantum computers faster and more efficient. The research suggests that if light can be converted into a supersolid state, it could lead to a lot more breakthroughs. This could also be used to create robust quantum networks that would make the transfer of information extremely fast and secure. In the future, this discovery could revolutionize fields like advanced laser technology and light-based computing. This experience could help us better understand the relationship between light and matter. It's possible that we might uncover some mysteries of quantum mechanics that are still unknown. Another intriguing question is whether we can fully control light. Scientists don't really know much about this right now, but this experiment could be a big step towards answering that question. If light can be frozen, it means that in the future, we might be able to slow it down or even pause it temporarily. There have been successful attempts by scientists at Harvard University and MIT to significantly reduce the speed of light, but fully freezing it has so far been limited to a few experiments. During the experiment, scientists used an ultra-cold atomic gas known as Bose-Einstein condensate. When light passed through this special medium, its speed dropped from about 300,000 kilometers per second to just 17 meters per second, which is roughly the speed of a fast runner. This research turned out to be really important for quantum physics, optics, and data storage. It demonstrated that while the speed of light is usually considered constant, it can actually be slowed down under certain conditions. This is a groundbreaking discovery. Experience tells us that light isn't just a wave of energy. It can also be trapped in a specific mechanical arrangement. This finding poses a huge challenge to our current scientific theories. According to scientists, this research could open a new chapter in the world of quantum physics. They're conducting experiments to better understand this discovery and to figure out how to shape light into more complex quantum states. If this experiment succeeds, the next step might be for scientists to explore other quantum phases of light. Maybe one day we'll be able to completely turn off the light. This discovery can help us understand the subtle differences between light and matter, and it might pave the way for new light-based technologies in the future. This scientific achievement shows us that we're still uncovering the fundamental principles of nature. And even something as basic as light holds mysteries that we haven't fully grasped yet. This experience has placed us on the threshold of a new quantum era, opening up new possibilities for the nature of light. Are there going to be more surprising discoveries? Can light really be completely organized? If that's possible, what would the implications be? These are the questions that scientists might only be able to answer in the future. Lastly, I want to ask you, could this research bring about a new revolution in the world of quantum physics? What do you think? We're waiting for your thoughts in the comments section. So that was today's video. I hope you found it really informative and interesting.